Hello, I'm Pavel, and this is a poster about correcting stem distortions in atomically resolved elemental maps. It's related somehow with another hour poster in this conference about correcting distortions in simple stem images. But in the case of elemental maps, the problem is even magnified, because spectrum imaging, either with EELS or EDX, typically requires an order of magnitude longer acquisition time than conventional STEM. Therefore, if there are some instabilities in your system, they will be dramatically magnified in elemental maps. How to correct for that? Well, typically, during spectrum imaging, you take not only spectra, but also simultaneously ADF signal, and all stem distortions are very clearly seen in this simultaneous ADF image. On the other hand, prior spectrum imaging, you take a so-called overview ADF image, just to select the area you want to map. And this ADF image is fast scanned, so the distortions there are minimal. Well, they exist as well, as discussed in another hour poster in this conference, but comparing to spectrum imaging, it's nothing. So why not use a fragment of this fast scan image as a reference to correct spectrum image? We warp our simultaneous ADF image such as it fits best the reference. And of course, ADF image is improved, but it's not our target. Our target is to retrieve certain warp curves that provide best correspondence, best transformation between spectrum image and reference. Then simply apply exactly same transformation to elemental maps, and you see that they are greatly improved. Additionally, our script performs upsampling of elemental maps according to more dense sampling of overview image, typically more dense, which doesn't bring some extra scientific information, but just improves a bit the appearance of elemental maps. Thank you. I'm excited about your questions.